Page 113, parallel and perpendicular okay. So before we get started on our notes, we're going to be talking about parallel and perpendicular lines, and one of the things I first want you to look at is actually our first day of notes ever, where we talked about parallel, perpendicular, and skew lines. This is literally on like page 5. It's the first page we've ever done. Okay, so parallel lines never intersect, and they're on the same plane. So what does that look like? These two lines are parallel. They will never well, if my pen and my marker are lines, they're parallel, they will never intersect. Okay, they'll keep on going forever and ever. They are touching the same plane. They're parallel. Perpendicular lines are on the same plane, but they form a right angle. And skew lines are two lines that are never going to intersect, but they're on different planes. So if you notice here, if I rotate this, see how these two writing utensils, they're on different planes, and they don't have the same slope, but they're never going to intersect. Okay? So if you kind of look at it from the side, that's kind of what it looks like from the side. If we're talking about on a, I can even add to this down here. If we're talking about in a rectangular prism, okay, line AB and CD, so AB and CD, they're on different planes, but they're not parallel. So they're never going to intersect, or they're not on the same plane. They're never going to intersect, but they aren't parallel. So they're kind of like off from each other. So that's kind of the words we need to keep in mind today. So two lines are parallel if they're on the same plane and they never intersect. Two lines are skew if they are on different planes and never intersect. And two lines are perpendicular if they're on the same plane and they intersect at a right angle. So our objective today is to create equations that have parallel or perpendicular slopes. Okay, let's start with the definition of parallel slopes. Parallel slopes have the same slope. Okay, so y equals 3x plus 5 is parallel to y equals 3x minus 10. They have the same slope, but different y-intercepts. So maybe we should add that on there. Parallel slope, same slope. Okay. Perpendicular slopes. Okay. If parallel slopes are same slopes, perpendicular slopes are totally opposites from each other. They are negative reciprocals. So A over B, if I had, yeah, that's so messy, A over B. If some slope was A over B, it's negative I'd flip it and negate it. So A over B is a negative reciprocal of negative B over A. So if I was talking about two lines that were perpendicular, maybe I'd y equals 3x plus 5 is perpendicular to y equals negative 1 over 3x minus 4. I don't know. Doesn't matter what the y-intercept is. Okay? So these are negative reciprocals. Here my slope is 3 over 1. Here my slope is negative 1 over 3. So their slopes are negative reciprocals, so they are perpendicular. Okay, so let's talk about finding the equation of a perpendicular line. Okay. So let's say I wanted to write the equation of a line perpendicular to I personally only like to remember one equation of a line. I like to remember the equation of the line y equals mx plus b. The other one's good to know, this one's need to know. So to write this equation, I need to know the slope and the y-intercept. Okay, if I wanted to make a perpendicular line to this, whose slope is 1/2, the negative reciprocal of 1/2 is -2/1. Some other information that I know about this line that I'm creating is that it goes through the point x, comma y, or 4, -2. So I know that x is 4 and y is -2. Now if I wanted to, I could just fill in y minus y1 equals m times x minus x1. I could just do that.
Mr. Prendergast, please call B213.
But this is a lot of extra work, in my opinion, and it's extra to remember. So I'm going to show you how you can find the y-intercept without using this and just using this. So I know 3 pieces of information, and here I have 4 variables. So this is nice because with 3 pieces of information, I can find the 4th variable. So what I'm going to do is I'm going to plug in for y, for m, for x, and I'm going to solve for b. So -2 equals -8 plus b. When I add 8 to both sides, I get that 6 is b. So when I write the equation of the line, y equals m, using my perpendicular slope, plus, or excuse me, mx, plus b, which is 6. So that's the equation of my line. Okay. So let's say I wanted to get a little bit more complicated. Okay. So if I wanted to do a parallel line, okay, I would do the same thing, except for I would use the same slope of 1/2 to solve this. So instead of using -2/1 to find a parallel line, I'd just use 1/2. Let's say I wanted to find the equation of a perpendicular bisector. So let's say I had determine the equation of the perpendicular bisector of 1, 4 and 3, 12. Okay. So I need to know 2 things. First, I need to find perpendicular slope, and I need to find the point that's in between these. So I need to know the midpoint. So let's start with the easier route here. First, I need the midpoint of these 2 points. So I'm first going to find the midpoint. So that's change in y over change in x. So 12 minus 4 over 3 minus 1. So 12 minus 4, 3 minus 1, keeping those points in order, second point, then first point. So m is 8 over 2. My slope is 4. Okay. Well, I just found the slope, not the midpoint. Sorry, guys. So that's the slope of between these 2 lines. The midpoint is the average of the 2 points. So 1 plus 3 divided by 2, and 4 plus 12 divided by 2. So the midpoint in between here is 2, comma, 8. So the slope of 4 is the slope of the original segment. I need the perpendicular slope. So the perpendicular slope of 4 is negative 1 over 4. So this is really 1, and the reciprocal would be 1 over 4, and make it negative. So I want the slope that goes through this point. So negative 1/4 would be my slope, and I want it to go through the point 2, comma 4. Or excuse me, 2, comma 8. So x is 2, y is 8. So again, I'm going to use y equals mx plus b. I only really need my b because I have my slope, so I need to find b. So y is 8, m is negative 1/4, x is 2, plus b. When I solve this, I get 8 equals negative 1/2 plus b. So b is 8.5. So when I write the equation of my line, negative 1/4 x plus 8.5. That is the perpendicular bisector between those two segments. That's it.